Afternoon, everyone. Myself, Kuncha Lakshmi Prasanna, working as Assistant Professor in School of Agriculture, Department of Soil Science and Agriculture Chemistry, SR University, Warangal, Telangana. So today I'm going to teach the topic that is physical problems in soil. So let me give a very few introduction about the physical problems in soil. The soil is a complex system which comprises of mineral matter, organic matter, soil air and soil water. Soil physical properties plays a crucial role in maintaining the plant growth, water balance, sustain various ecosystems or habitat to the various ecosystems in the environment. However, soils also have various physical problems which impair their functional growth or functional growth in the plants and also in the soil. So some of the physical problems in soil like soil compaction, soil crusting, soil erosion, soil degradation, so which are discussed in the further slides in detail. So first constraint is the soil compaction. So soil compaction refers to the formation of thin compact layer having high bulk density, high penetration resistance at the surface of soil. Soil compaction is mostly present in the regions that is the arid and the semi-arid regions. So their thickness ranges from less than 1 mm to the 5 centimeters. Soil crusting mainly occurs when the soils are dry. When soils are dry, soils become more compact, hard than the underlying soil materials, which decrease both in size and also in the number of the pore spaces, which also modify the management of or the arrangement of the pore system. In the temperate areas, surface thrust mostly develop on the loamy soils. So mechanism of soil crust formation. So this diagram depicts the mechanism of soil crust formation. So first is the mechanical destruction of aggregates, washing in layer. Next, that leads to the reorientation of the soil surface. That leads to the cementation and the compaction of soil particles. Then finally, there is formation of the structural or the depositional crust. So mechanism of soil crust formation. So in the mechanism of soil crust formation, so first is the mechanical destruction of the soil aggregates. So mechanical destruction of the soil aggregates are mainly found by the high impact of the raindrops. Next is so when there is high impact of raindrops, then obviously the leaching of the soil particles or the leaching of the top layer of soils gets eroded. That is washing in layer takes place. Next is the compaction of the soil surface, which leads to the thin film, which restricts the entry of water and movement of the fine particles within the soil pores. Next leads to the cementation of the slaked soil, which occurs during the drying or the reorientation of the soil surface. Next, upon drying, the orientation of the particles would contribute to the rigidity of the soil crust. Next is the characteristics of soil crust. First is the mechanical strength. Next is the low porosity, higher bulk density, higher CEC, reduced infiltration rate, higher runoff, which leads to the reduction in the soil moisture. Next point is the impact of soil crust on the soil and the plant growth. So due to this soil crust, which impacts soil or the plant growth effectively, like it prevents the germination, prevents or hampering of the seedlings of germination and also retard the root growth. It also results in the poor infiltration rate. It also accelerates the surface runoff. It creates the pore aeration in the rhizosphere, that is in the root zone area of the plant. Next, it also affects the nodule formation in the leguminous crops. Next is the measurement of soil crust strength. So how do you measure this soil crust strength? So it is by the various parameters like so we use different methods for the measurement of soil crust strength. It is by the modulus of rupture test. Next is the soil penetrometer. Next is the fishing line and hydraulic balloon test method. Next is the seedling emergence method. So these are the methods we use for the the determining this soil crust strength in the soil. Next is the remedial measures for the soil crusting. So there are different remedial measures in order to prevent this soil crusting. So it is like crop rotation, application of lime or gypsum at the rate 2 ton per hectare, and application of FIM at the rate 2.5 ton per hectare. Next is the reduced tillage or the no tillage, which is the best method for to prevent this formation of soil crust. Next, usage of the soil conditioners as like chelates. Next, maintaining of crop residues on the soil surface, that is the crop residue management. Scraping the surface of soil by tooth harrow, which will be more useful. Bowl seeded grains are mostly used for sowing, that is in the soils having the more crust formation. Next is the more number of seeds to be adopted for the, or more number of seeds to be grown for a small seeded crops. Next, sprinkling of water at the periodic intervals. Next remedy is resistant crops like cowpea or the pulse crops can be grown, so that the soil aggregates will be in a very stable manner. Next constraint is the soil compaction. So soil compaction, what do you mean by soil compaction? Soil compaction refers to the compression of soil particles into a smaller volume, which reduces in size of the pore spaces available for the air and water. Most of the soil is composed of 50% of solid space and 50% of the pore spaces. So among this 50% of the solid space, it contains this sand, silt, clay, and the organic matter. In the 50% of the pore spaces, it contains this 25% of soil air and 25% of soil water. Soil compaction can be a serious form of soil degradation. Here you can see the picture depicting this compacted soil where the soil particles are held very close together, where there is very less space for the space available for the formation of air or the water in between the soil particles. Next is the causes of soil compaction. How this soil compaction occurs in the soil. So soil compaction occurs mainly by the various activities like heavy machinery and the usage of heavy machinery and equipment, livestock grazing, tillage practices, soil moisture content levels in the soil. Next is the soil texture and the organic matter levels. So by the usage of this heavy machinery or the heavy equipment. So when we are using this heavy machinery or heavy equipment in the fields as like tractors, harvesters. So because of the high intensity of these heavy equipments, the soil is pressed repeatedly. When soil is pressed repeatedly, the soil particles, soil structure is damaged. So this condition is mostly seen on the wet soils. Next is the livestock grazing. So continuous grazing by the livestock, especially in the same area over a long period of time due to the animal hooves, can deteriorate the soil surface. That is the top fertile layer of soil gets eroded because of the animal hooves. Next is the tillage practices. Excessive or improper tillage practices, especially with usage of heavy machinery, can disturb the soil structure. Over time, this creates the compacted layers which are known as the hot pans, which is formed below the tilled surface. Next is the soil moisture content levels. Soil is more prone to this compaction when it is in wet condition because water fills the pore spaces, making the soil particles easier to compress. Next is the soil texture and the organic matter levels. Clay soils are more susceptible to the compaction due to their fine particles. As the size of the clay particles that is less than 0.02 mm, As the size is very small, these clay soils are more prone to this compaction. And also the soils having the low organic matter levels reduces the soil structure, making that soil more prone to the compaction under the high pressure. Next is the effect of soil compaction on the soil properties. So when we see the effects of soil compaction on the soil, so this soil compaction leads to the reduced water infiltration. Infiltration rate in the soil is reduced because of the soil compaction. Next is the decrease in the rate of water penetration into the soil root zone and the subsoil. Next is the reduces water holding capacity to water and air. And next effect is the reduces crop emergence as a result of soil crusting. Next is the limits the soil exploration by the roots. I mean, the root system of soil, root hairs of the soil is getting decreased, which decreases the availability of nutrients. Thereby, it reduces the yield potential. Next, it increases the potential for the surface water ponding, water runoff, and water logging condition and soil erosion. So these are all the surface water ponding, water runoff, water logging condition, and soil erosion conditions. These are all the effects which are seen on the soil because of this soil compaction. Next constraint is the subsurface hot pan. So subsurface hot pans is one of the physical constraints present in the soil. It is mostly found in the red soils. Though the red soils are more fertile, crops cannot absorb the nutrients from the soil. It is because of the reduction in the crop yields, which leads to the reduction in the crop yields. So the reason behind this, the formation of subsoil hot pans in the red soils is because these red soils have the characteristics like elevation of clay to the subsoil horizon. So elevation of clay in the subsoil horizons is coupled with the cementing action of oxides of iron, aluminium, and calcium carbonate. So elevation of clay in the subsoil horizon in combination with the cementing action of these oxides, iron, and aluminium and calcium carbonate. All these phenomena, all these activities takes place in the red soils. That is why the subsoil hot pans are more commonly seen in the red soil. So here you can see this picture depicting this topsoil layer and the compacted hard layer which is present below the topsoil. I mean, it is a very compact, it is a very fine thin layer which is very hard in nature, which does not make the root system to penetrate inside. Roots cannot penetrate the hot pans, leading to the reduction in reduced crop growth. So this is how the compacted soils makes the root system unavailable for the absorption of the nutrients from the deeper layers of the soil. Next is the impact of hot pans on the soil physical properties. How the impact of hot pans occur on the soil physical properties. It is mainly characterized by the high bulk density, which in turn lowers the lowering of the infiltration rate, water holding capacity, availability of water and available water, and also movement of air and nutrients. Movement of air and nutrients and available water is also reduced. Drastic effect on the yields of the crop. Next is the chisel technology. So chisel plow technology is one of the best technology that is used for the breakage or to overcome this subsoil hot pans. So chisel plow technology helps to break the hot pan in the subsoil, which is besides the plow up to the 45 centimeters depth. So along with this, the farmyard manure or the press mud or composted coir pit at the rate 12.5 tons per hectare should be sprayed evenly on the surface of the hot pans. Next, the field should be plowed with country plow twice for incorporating the added manures. Then the broken hot pans and incorporation of manures make the soil more in order to conserve the more moisture. So this is how the we can say that the chisel plow technologies is a very best method for the very best method to overcome this subsoil hot pans. Next constraint is the soil erosion or eroded soil. So eroded soil is one of the major constraint which is mostly seen in the arid and semi-arid conditions. So soil erosion, the word erosion depicts the detachment and transportation of soil mass from one place to the other place, that takes place through the action of wind, water in motion, or by the beating action of the raindrops. This is known as the erosion. Erosion extensively occurs in the poorly aggregated areas, poorly aggregated soils, that is the soils having the low fertile soils or the soils having the low organic matter levels, and the soils having the high percentage of the silt and very fine sand. Erosion increases when the soil is very bare or or when there is without vegetation. If we see the soil erosion in the perspective of India, in India it is about 86.9% of soil erosion which is caused by the water, 17.7% soil erosion is caused by the wind. So 86.9% of erosion is caused by the water and 17.7% is erosion is caused by the wind. Out of 173.6 million hectares, that is the total degraded land in India, soil erosion by the wind and water accounts for 144.1 million hectares. In India, it is 16.35 ton per hectare per year of soil is eroded annually due to the agriculture or its associated activities, and 29% of land is eroded permanently and it is lost into the sea. So this is a few aspects regarding the erosion, soil erosion in the Indian perspective. Next is the process of soil erosion. Process of soil erosion occurs in 3 different steps, that is the detachment, transportation, movement, and deposition. So here you can see the diagram depicting the process of soil erosion. So after the impact of the raindrops, after the rain, due to the impact of raindrops, there is detachment of soil particles. The soil particles are detached and it moves from one place to the other. That is known as a detachment. So after the detachment, it is transported from one place to the other place. That is known as the transportation. Next is the translocation. So after transportation, the particles which are moved from one area to the other area, it gets settled over one place. That is known as the translocation. Next is the deposition. This is the final step where this soil erosion takes place. So in this manner, there are 4 steps, that is detachment, transportation, translocation, and deposition. Next, we are seeing these types of soil erosion. So in the types of soil erosion, there are 2 different types, that is natural soil erosion, natural or geological erosion, or the accelerated erosion. So here, the natural or geological erosion. So the word itself says that the erosion which takes place in the naturally within the nature, that is known as the natural or the geological erosion. So it mainly takes place in the protective cover of the natural vegetation, completely undisturbed by the biotic interference. So this natural erosion, you see, it takes a long time, slow eroding process that has developed various topographic features like stream channels, valleys, canyons, through tile effect of water, through the different effects of water, wind, temperature, and also the living organisms. Geological erosion also takes place steadily, but it is very slow in nature, and it makes the alteration in the major features of the Earth's crust. As that is why the name suggests that it is a geological erosion. So here we can say that there is always equilibrium between the removal and the formation of soil. So next type of soil erosion is the accelerated soil erosion. So accelerated soil erosion is a type of erosion which is mainly caused by the disturbances caused by the man, animals, along with the nature equilibrium activities like wrong land management, over exploitation of forest, natural vegetation, overgrazing. So these are all the conditions which are favorable for the formation of this accelerated soil erosion. So as you all know that, so for the formation of, so nature requires on an average 1,000 years to build 2.5 centimeters of topsoil. But due to the wrong cultivation practices or the wrong agriculture activities or wrong management practices which are done by the human beings, may take only because of these activities, it takes only a few years to erode it. So for the formation, it takes some 1,000 years. So, but to destroy the top layer of soil, it takes within a span of seconds to get the soil eroded or destroyed. Next aspect is the type of erosion. So here, in the type of erosion, first we are going to see this wind erosion. So wind erosion is the erosion which is erosion of soil by the action of wind. Erosion of soil by the action of wind, which dislodges the soil particles from one place to the other place and gets deposited in the other place. That is known as the wind erosion. So wind erosion is of three types, that is saltation, suspension, and surface creep. Okay. So here you can see the picture which depicts these types of wind erosion, that is saltation, suspension, and surface creep. So let's see one by one. So first is this saltation. So the saltation, which is formed by the bouncing or jumping of the particles over the surface. Bouncing or jumping of particles over the surface, it is the formation of the saltation. So bouncing or jumping of the particles takes place because of the wind force which lift the particles almost vertically into the air. So when the particles move into the air vertically, these particles rotate several hundred revolutions per second and travels 10 to 15 times than their height in rise. So the particles size ranges from 0.1 to 0.5 mm in size. So this is regarding this saltation, that is the bouncing of jumping of the particles one over the other. So next is the suspension. So suspension, here the particles ranges from smaller than 0.1 mm in size. So here as the particle size is very small, the soil particles are lifted high into the air, which may be carried through many miles. So as the particle size is less than 0.1 mm, the particles are carried into the air many miles when the wind movement is initiated. So that is regarding this suspension. Next is the surface creep. So surface creep is the rolling or sliding of soil particles along the surface. Rolling or sliding of soil particles along the surface. So here the particle size varies from 0.5 to 2 mm in size. And the rate of movement of soil particles in surface creep is proportional to the cube root of wind velocity. So as the particle size are very high in nature, as the particle size is too high, the particles are lifted by the wind and therefore they are rolled by the impact of the smaller particles in the saltation. So here you can see the size of the particles in the surface creep. The particle size is very big when compared to this saltation or the suspension. That is why the particles are lifted up. They are lifted by the wind and therefore they are rolled by the impact of the smaller particles in the saltation. Next is the Next type of erosion is the water erosion. So water erosion, what do you mean by water erosion? Water erosion is nothing but the removal of soil from the land surface by water, which includes runoff or from the melting of snow or ice, is termed as the water erosion. So water erosion occurs in different stages like splash erosion, splash or raindrop erosion, sheet erosion, rill erosion, gully erosion, and stream bank erosion. So here you can see the picture depicting these all types of erosion, that is splash, sheet, rill, and stream bank erosion. So first we'll see this one by one, that is splash erosion. So splash erosion occurs when there is when raindrops strike to the ground surface, the soil particles become loose and splash due to the impact of raindrops. The raindrops falling on the surface acts as the intensity of that particular raindrops is at 75 centimeters per second, is capable of creating a force of almost 14 times of its own weight. So the forces which influence this splashing effect are mass of raindrops, mass and also velocity of raindrops, and also soil characteristics like such as roughness, surface slope, and aspect. So these are some of the characteristics which leads to the erosion in the soil. Hydraulic conductivity, moisture content, particle size, elasticity, and the mass of the surface. So these are all the soil characteristics which leads to the splash erosion. So here you can see the picture which depicts this splash erosion. So when the rain falls on the surface of the ground, so due to the high intensity of this raindrops, the particles which are held very loose, I mean the soil particles or the soil having the low organic metal or roughness of soil, or if the slope is very high, or when the particles are very loose in nature, because of the high intensity of the raindrops, the particles are broken down and it is detached from one particle to the other particle. So here you can see the detachment of the particles, and then after the detachment, they are transported from one area to the other area. Then they are resided in our one area, that is the translocation, and deposited in one place, that is the deposition. Next is the sheet erosion. So sheet erosion is one of the very dangerous erosion. So this type of erosion, we can also say that this is the only erosion which is unnoticed by the farmer. So sheet erosion is nothing but the erosion, that is the uniform removal of soil in the thin layers. Uniform removal of soil, uniform removal or the removal of top fertile layer of soil in the thin layers from sloping land caused by the sheet or overflow of water. So the breaking action of the raindrops combined with the surface flows is the major cause for the formation of the sheet erosion. And it is the type of erosion which is unnoticed by the farmers. Sheet erosion is the most severe problem which is mostly seen in the red soils. So the annual loss of the topsoil, which ranges from 11 to 43 tons per hectare. So here you can see the diagram depicting the sheet erosion. So this is the sheet erosion, that is the removal of top fertile layer of soil along with the runoff water. So this is known as the sheet erosion. Next is the rill erosion. Rill erosion is a type of erosion which comes under this water erosion. So rill erosion is nothing but the erosion which is the removal of soil by the runoff water with the formation of shallow channels that can be smoothed out completely by the normal cultivation practices. So even though when there is formation of rill erosion, we can make the land even by doing certain cultivation practices. So rills are formed as a result of the concentration of the runoff water, where the silt runoff water starts flowing along the slopes through small finger-like channels. That those are known as the rills. Rill erosion is the incipient form of gully erosion. If rill erosion is continuous only for a short period of time, then we can make the land, we can repair the land, or we can make the land even by doing certain tillage practices. This is known as the rill erosion. Next is the gully erosion. So gully erosion is a type of erosion which is the extended form of the rill erosion. Extended form of rill erosion is known as the gully erosion. So gully erosion is formed by the volume of concentrated water. When the volume of concentrated water increases, it attains more velocity on the slopes, which enlarges the rills into gullies and valleys. So this picture depicts the formation of extension form of rills into gullies and thereby formation of valleys. However, when the rills are so deep, the ground cannot be smoothed out with the tillage practices. So as the gullies are very deep in nature, we cannot make the land, or we cannot repair the land by doing certain tillage practices. So gullies are sometimes very deep in nature. It ranges from 16 to 12 meters. 16 to 12 meters depth. Next is the effect of soil erosion. So there are different effects of soil erosion. That is the loss of top fertile soil. Loss of top fertile soil is by the surface runoff, accumulation of sands or the other soil materials on the productive lands. Next is the siltation of lakes or the reservoirs. So siltation of lakes or the reservoirs occurs mostly in the catchment areas where these because of the siltation of lakes or the reservoirs, the capacity of the reservoirs is reduced. The capacity of reservoirs for the storage of water is reduced. Next, siltation of drainage and water channels by deposition of silt in the drainage ditches, by the siltation of drainage and water channels by the deposition of silt in the drainage ditches, thereby reduces the depth and also capacity of overflows. Next is the decreases the water table. So soil erosion also leads to the decrease in the water table. It is because when the surface water is high, the water cannot penetrate inside the soil surface. When soil cannot penetrate into the soil surface, then obviously the recharge for the groundwater is reduced. When the recharge for the groundwater is reduced, then obviously there is decrease in the water table. Next is the fragmentation of lands. So there is fragmentation of lands, like formation of rills, gullies, and valleys because of the formation of channels in a very deep in nature. Next is the factors affecting this soil erosion. So there are different factors which affect the soil erosion. One is the climate. So the factors of climate includes this precipitation, wind speed, temperature, humidity, radiation. So these are all the climate factors which affects the soil erosion. So the wind erosion is more commonly in the arid climates than in the wet areas. So erosion mostly takes place in the arid and semi-arid condition when compared to the wet areas. Arid and semi-arid soils are more vulnerable to the wind and water erosion because they contain this less organic matter. In the meanwhile, they also contain this less fertile layer of the soil. So the next factor is the soil properties. So soil properties, which includes this soil texture, soil structure, organic matter, nature of clay, and the amount of salts present in the soil. So generally, the fine textured soils or the alkali soils are more erodible in nature. On the other hand, the soils having the low silica sesquioxide ratio. The soils having low silica sesquioxide ratio. So these type of soils which are mostly present in the humid tropics, that is the lateritic soils. So lateritic soils are the type of soils having the these soils are reported to be less erodible in nature. Next, the soils having the great absorption or retentive capacity of water reduces the runoff, thereby it is very less erodible in nature. And also the core structure soils containing the greater proportion of sand are more susceptible to this wind erosion. Next factor is the topography. So topography plays a major role in the type of erosion. Slope accelerates the erosion as it increases the velocity of flowing water. Slope or aspect accelerates the erosion as it increases the velocity of flowing water. So it is said that the 4-time increase in the degree of slope. So the 4 times increase in degree of slope doubles the velocity of flowing water, which increases its erosive power to 4 times and silt carrying capacity of 32 times. So mostly the lateritic soils having this rolling topography, lateritic soils which are present mostly in the high rainfall areas having this rolling topography may suffer mostly with this sheet and the drill erosion. And also these different aspects of slope like steepness of slope, length of slope, configuration, variations in the steepness, microtopography, aspect of slope. All these are the factors which affects the soil erosion. Next factor is the biological factor. So biological factor of soil includes this vegetation, residues, mulch, animals, shifting cultivation. All these are the practices which are mostly practiced in the hilly areas. So heavy destruction of forest and grasses. So when there is heavy destruction of forest, that is a deforestation, and accelerates when the deforestation is more in the hilly areas. It is one of the place where there is a chance for the erosion development. And also one more component is the shifting cultivation. So shifting cultivation, which is mostly occurring in the hilly areas. So where there is without any protective structures or where there is no protective structures for the soil. So the erosion is more prone to these areas where there is more amount of shifting cultivation. And also the animal trafficking, animal trafficking also destroys the natural vegetation and it exposes the soil surface directly to the sunlight, thereby reducing the organic matter level, and it causes the soil degradation. Forest and grasses also provide better cover than the cultivated crops. Lack of vegetation creates the erosion permitting conditions. So when there is no vegetation which is grown on the land, then obviously that particular land is more prone to the erosion when compared to the land having the vegetation. So when the vegetation is grown on a particular land, so the land is less susceptible for the falling of raindrops, and thereby the surface runoff or the other conditions of the impacts of the erosion can be decreased when there is vegetation on the particular land. Next is the solutions for the soil erosion. So there are different solutions for the soil erosion. So we can go for the crop rotation, contour cultivation. So contour cultivation, which is mostly grown in the slopy areas. Next is the strip cropping. Next is the terracing. Next is the grassed waterways. Next is the diversion structures, drop structures, till planting, chiseling, crop residue management. So these are all the various aspects which are the remedial measures, or we can say that these are the solutions for to prevent the soil erosion. So thank you.